Alright, good day guys and welcome to Abyssinian Educational. Today we will discuss about the calculations involving concentrations of sodium hydroxide, which is an alkali, and this acid. The whole process, the whole reaction is known as the process of what? Neutralization, am I right? It's a process of neutralization whereby you have an alkali that react with hydrochloric acid or any other particular acid, and for the matter of fact, and salt will be produced plus water. And some books will put this as not just an alkali, they just say this is also a metal hydroxide in the chapter of acid, bases and salts, right? You will know that this is a metal hydroxide. Any metal hydroxide react with any acids will produce salts and water only, right? Okay, let me just erase this one for a while so you have a better picture. So we are given this what do you call this, sodium hydroxide, okay, that react with acid, and the concentration of your acid is given as 0.1 mole per cubic decimeter, and you're only going to use 25 cubic cm of it, and you're also given a volume of 23 cubic cm of sodium hydroxide. And the question asks you, what is the concentration of sodium hydroxide solution? Well, it looks quite difficult. No, it's not as difficult as you think. Don't worry about that. Okay. So let's go through the acid first. Right? What can we get from the acid? Okay. The acid is given as 25 cubic cm, right? And the concentration is 0.1 mole per cubic decimeter, right? Okay, from the balance equation, we have 1 mole of sodium hydroxide react with 1 mole of hydrochloric acid. Okay, so from there, we use the one that is given to us. Is the question says 0.1 mole per cubic decimeter. That will give you 1000 cubic cm. The reason why you have to convert to cubic cm is because they said they only use 25 cubic cm. So 25 cubic cm corresponds to how much? What's the mole? Very easy. 25 cubic cm divided by 1000 cubic cm. You multiply that with 0.1 mole. That will give you how much? That will give you 2.5 times 10 to the power of negative 3 of a mole. Okay, that will be the mole of your acid when you use only 25 cubic cm of this particular concentration, 0.1 mole per cubic decimeter. So that you're going to use 22.5 times 10 to the power of negative times 10 to the power of negative 3 mole of an acid. So because of the fact that we use only 20 cubic cm, and of course we are told that they use what? Sodium hydroxide, right? So your sodium hydroxide is what? Given as 20 cubic cm, and 1 mole of the alkali react with 1 mole. Therefore, if you use 22.5 times 10 to the power of negative 3, right, of a mole in your acid, that means your alkali will also use the same amount. Am I right? Okay, that means your alkali sodium hydroxide will use exactly the same amount as 2.5 times 10 to the power of negative 3 mole. Okay, with that knowledge, I go to the next page so it's easier for you. It means 2.5 times 10 to the power of negative 3 mole of sodium hydroxide, NaOH. That will correspond to 20 cubic cm because you are using only 20 cubic cm. And in any concentration, it will be per cubic decimeter. So 1 cubic decimeter is 1000 cubic cm, right? That will give you how much more? Very easy. 1000 divided by 20. Alright. You multiply that with 2.5 times 10 to the power of negative 3 mole. That will give you 0.125 mole. Therefore, the concentration of your sodium hydroxide is 0.125 mole per cubic decimeter, right? 1000 cubic cm is 1 decimeter. Am I right now? Simple, isn't it? So this is your answer. As simple as that. all right, without using all those crazy triangle, those with this thing, such as what they tell you the number mole over what mass substance. Ayo, so difficult, right? You don't have to memorize all those crazy triangle. Okay, it's no time. I myself do not memorize it, so why must I torture you? Okay, we have thousands of formulas for just for the mole concept. Okay, that's all, folks. I hope to see you again for some other examples, and if you have other examples, you can always comment on my page. See you. Thank you. Have a nice day, babe.